today's lesson 7.4, Equations with Rational Expressions, we'll be taking a look at just a few examples of how to basically solve an equation that has fractions in it. You'll notice that this will be very similar to what we did in the previous sections. What we're going to do is we're going to take a look at our equation, negative 3 over 20 plus 2 over x equals 5 over 4x. And just like the last section, we're going to try to find an LCD. And again, it's what you have to do to make them in common. So our denominators being 20x and 4x. The LCD here is going to be 20x. And then you need to kind of figure out what you need to do to put each of those into the equation. In the first one, it already has 20, so I need to add an x and an x to the numerator and the denominator. In the second equation, I'm going to have to multiply it by 20 over 20. And finally, in the last one, I'll have to multiply by 5 over 5, because the 4 times the 5 will give you the 20. Once you then multiply the equation, or the part that you're putting into the fraction, negative 3x, 20x, plus 40 over 20x equals 25 over 20x. You should notice that all your denominators are the same. That's going to work out really nicely for us because we're going to use the distributive property, and we are going to multiply the entire equation by the denominator. Now this is where it differs a little bit from just expressions instead of equations. So when I multiply by 20x, what will happen is I'm going to do it to every single term, and it will cancel out with every denominator. So this will cancel here. When I distribute it to the second one, it will cancel out the denominator there. And finally, the third, it will cancel out the third denominator. And you will get negative 3x plus 40 equals 25. Then you'll solve for your variable. And you get 5. And from there, if you want to test it or double check it, you plug it in for your original equation. 2 over 5 you'll need a common denominator here, so that's going to become 8 over 20. And you notice that it will check out. Problem number 2 is a little bit more complicated. You'll notice that we have some binomials in there. We have 3 over x plus 1 equals 1 minus x minus 1 minus 2 over the quantity x squared minus 1. Again, what you want to do is you want to find your LCD. Now, if you see something a little bit more complicated, you're wanting to see if it will factor. X plus 1 is in lowest terms, as is x minus 1. But you should notice that x squared minus 1 is actually a dots problem, and it's factorable. X plus 1, x minus 1. Now that works out pretty well because it's pretty close to the other ones. So if you look at it, the LCD, this one's just missing the x minus 1, this one's just missing the x plus 1, and that one has both. So the LCD will be x plus 1 times quantity x minus 1. So again, you need to think about what needs to be added to each fraction. X minus 1 needs to be added to the first one, and x plus 1 needs to be added to the second, while the third one is technically already there because we'll factor it to those binomials. From there, I'm going to distribute the quantity added in, so 3x minus 3 for the first one. And then I'm going to leave this separated as two binomials, and I'll show you why later. It helps kind of reduce it faster if it's already factored. I'll distribute the 1 right here so it remains the same. And again, my denominator, x minus 1, x plus 1. And that third fraction stays the same. And again, like we saw in the previous, those are all the same. So if I multiply the entire fraction, or I'm sorry, entire equation by the LCD, it's going to cancel out here. When I distribute, it'll cancel out here, and finally there. So I am left with 3x minus 3 equals x plus 1 minus 2. I'll go ahead and solve. Okay. And my solution is x equals 1. Now, here's the thing that we're going to do. We're going to double check this, just like we did in the last one. I'll get 3 over 1 plus 1. And then I'll get to the second one, and it'll be 1 over 1 minus 1. And you'll hopefully notice right away, 1 minus 1 is technically 0. So I have 1 over 0, which means that this right here is undefined. And you can't solve an equation with an undefined. So this right here is actually called an extraneous solution. It means when you go to solve and plug it back in, it really doesn't quite fit the problem, and the denominator doesn't work out. So since this doesn't work and there's no other solutions, there's actually no solutions for this problem. And our last problem for this section. I'm taking a look at, again, 3 different fractions. You'll notice that the denominators are more complicated. So again, what we're going to do is we're going to factor each one, see if we can simplify those a little bit more. The first one factors to be x plus 3, x minus 2. Again, 2 numbers that multiply to -6 but add to 1. The second one's a dots problem, x minus 2, x plus 2. And the third one, x plus 3, x plus 2. And from there, what I'm going to do is I'm going to compare and see what needs to be added in to get my LCD. So you'll notice there's an x plus 2 here, an x plus 2 here, but there's none over here. So I'm actually going to add an x plus 2 over here to account for that from the other fractions. So that's taken care of. Now I'm going to look at, I have an x plus 3 here. I don't have one here, so I'm going to add it into the third one. And then it's accounted for over here. And then finally, you'll notice there's an x minus 2 here. There's 1 in the second one, but the third one's missing it. So now if I compare it, they all match up. And there's actually 3 binomials. So my LCD is x plus 2 times x plus 3 times x plus 2 times x minus 2. I'll go ahead and distribute the numerators as needed. And then finally the last one, which will be 2x minus 4. And again, all over the 3 binomials. And we're going to make it simple again. We're going to multiply by that LCD. And again, you cannot do this in expressions, only with equations. That denominator cancels out. So we'll distribute, 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 and that will cancel, cancel, cancel. And then we can just go ahead and solve. Now the thing I want to point out in this this equation is it has a subtraction sign right here, you'll notice. That means you have to distribute it to both those terms. So it's going to be negative x minus 3 equals 2x minus 4. So we're going to get 3x plus 5 equals 2x minus 4. X equals negative 9.